Hello and welcome to the car. So today we're going to talk about speed and how speed affects things. Okay, so getting back to our favourite friends, the flat earthers, they have a real misunderstanding with what speed is and how it actually works. So we're travelling around the sun, which is travelling around the galaxy, which is travelling around the universe at inconceivable speeds. Totally get that reference, okay? I don't really know the maths there that well, but just because I don't understand something doesn't mean I don't get it, okay? Just because you can't feel the world going round spinning at 1,000 miles an hour doesn't mean it isn't happening. So the thing to think about is there's a difference between speed and acceleration. Okay, so we're traveling in the tropics at around 1,000 miles an hour, but that's at a constant speed. That isn't getting faster or slower. Now this, along with the moon and the sun, which is obviously the center of the gravity in our solar system. And how big is the solar system? Well, it's enormous, and our distance to the next solar system is so vast. It's inconceivable, especially when you think the world is flat. You're never going to be able to get your head around the distance between the sun to the next sun. So we won't even worry too much about that. But for those people who do have a basic understanding that we do live on a globe like what I does, if you take in the UK a 5p piece and shrink the whole solar system that we live in into that 5p piece, and then find yourself a football pitch and place it in a corner, and then have another football pitch the other side and put down a 5p piece, that's the rough distance that we are from one solar system to the next. The distances are vast, inconceivably long, so we won't worry too much. One of the other things that with distance they don't understand is how we can use lights from stars, which are potentially light years away, to help us navigate. Well, we do, or they used to. I don't. I use Google Maps, but there you go, that's just me. So why would I use Google Maps? Because it gives me a good view. It gets me where I want to. How does that work? Well, it uses satellites which are put up into space. Who does that? Oh well, there's companies like NASA that do that. So what I'm actually transmitting on is my phone. So at the moment I'm recording it. Later I may potentially edit it. That's unlikely because I don't normally. I will just check it for sound quality. But I will then take that and put it onto YouTube. Now, what YouTube will do is put it out to the world using things called satellites. Now, these satellites have been put up there by many different space companies, the most famous being NASA. Yeah, those who are famously guarding some imaginary ice wall, and if you get too close, they will shoot. Yeah, of course they will. Yeah, NASA, the nautical people, yeah, the ones that guard the world from going too close to the southern poles. Quick question here for you: who was doing that before? Because I'm not sure that there was anyone doing it before. I think it's just made up stuff. Anyway, we're going to get back to the main bit of the conversation, which was going to be the difference between speed and acceleration. So we are zooming around our sun at 1,000 miles an hour, rotating on this ball. Now, don't think of it as necessarily a spinning ball. This ball will take 24 hours to spin on its axis. So what that means is 1,000 miles an hour may sound fast, but to be fair, on the big scheme of things, it's traveling virtually unrecognizably. This happens, this is a thing. This helps us to stick to the ground because it helps form gravity. Gravity is also caused by our iron core. I did see something on one of my comments on my videos about gases and how gases aren't affected by gravity. Well, they clearly are, because if you were to climb up one of the big mountains, let's take Mount Everest in Nepal. You go climb up Mount Everest, you'll find that you're gonna run out of oxygen, or virtually run out of oxygen, because you're gonna go into the death zone where there's not enough oxygen to actually breathe. And that's because, who knew it, gases would be affected by gravity. I give you Saturn, I give you Jupiter as two primary examples. Great big balls of gas, humongous balls of gas to be fair. They are, well, gas. Jupiter has almost the same compounds and build-ups as our sun, so it's pretty much a big gas ball. The sun is pretty much a big gas ball, and I knew that was going to happen. There we go. Sorry about that. I need to sort out the holder, but I come into some traffic lights now, so we'll do that. Great catch there though, I hope. So after that world-class catch, we are back. Sorry about that. I knew that would happen eventually. It's not cool. I've got a little bit of the foam missing on one side, and it slipped. It's the foam slip. I will have to try and get a little bit of foam in there. Stop that happening. Big old lorry here. Yeah, you need to come first, mate, because you got a red light. That's it. Yeah, come on then. You might as well come as well. Right, it's me and the bus. We don't need to be going too far. So we're going to Asda because we need to get some flatbreads to work. That has nothing to do with anything to do with this video whatsoever, but I thought I'd share it anyway. So where was I? Oh yes, so speed and acceleration. So if you were to get a sports car, people think, oh, it's speed. And in Top Gun, finally say, I feel a need for speed. It's not speed that you feel there. It's acceleration. Okay, acceleration and speed are different things. If you go round a corner in a car or on a bike at extremely fast speeds, so we're looking at say 100 miles an hour into a corner, the force is G-force, and that is going to make you want to go forward, but you go around the corner and you can feel it as you shoot to one side. So you shoot towards one door or the other if you're in a car, depending on which way you're going. It's normally the opposite door to the way you're going, because that's the way the force wants you to go, and that's acceleration. So if the world was to speed up minutely, we wouldn't feel it, or slow down minutely, we basically wouldn't feel it. It would happen, and it would happen over a very long time. If, for example, all of a sudden the world stopped spinning, so it would go from its 1,000 miles an hour in the tropics to no speed at all, we'd all be flung about, because, and not just us, trees and everything, because the world has put the brakes on, and that's extreme. So 100% we would feel that. The same as if it all of a sudden shot up to 2,000 miles an hour from 1,000, we would feel that, guarantee it. However, if that was done on a macro way over hundreds or thousands or even millions or billions of years, we wouldn't feel it because it's unnoticeable. That's where acceleration and harsh braking, you notice these things because it's a force which is implied quickly. All this is learned in maths. If you take acceleration and you brake hard, then your speed has to go somewhere. So it's going to go into heat to warm up those brakes, because that's how stuff works. Anyway, this has been a beginner's guide to explaining how acceleration works, plus I'll have a load of nonsense in there which wasn't necessarily planned. This has been your man in the shed, Andy P. Hope you enjoyed the catch. It was incredible. I'm sure you agree. The part of the video I'm looking forward to. And yeah, see you, pals.